This is lesson 10.3, permutations versus combinations. So let's review things that we did last time with a little warm-up. A license plate number consists of 3 letters and 3 numbers. How many different arrangements are there? So we're going to use the counting principle here, right? So basically you have 3 letters and 3 numbers. How many different arrangements are there? So there are 26 letters in the alphabet. So you have 26 choices for each letter, right? License plates, you can repeat the letters, and you can also repeat the numbers. So the digits are 0 through 9. That's 10 digits, because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 possible digits. Okay? So we have 26 cubed times 10 cubed for our possible arrangements. So I'm going to type that into my calculator. 26 cubed times 10 cubed. And I get that there are 17,576,000 combinations. All right, next one. Mrs. Morgan had a class of 47 students. She needs 5 volunteers to help her. How many different ways can she pick the students? So in this one, she's just getting 5 volunteers out of 47. In this one, the order doesn't matter. So this one is a combination, right? So it's going to be 47 students, and we choose 5. So in my calculator, I'm going to go into functions and pick that NCR and type 47, 5, and we get 1,533,939, 1,533,939. Okay, so it's really important to know when you should use a permutation and when to use a combination. So permutations, we said back in the permutations lesson that it's when order matters. Like, for example, if you're rearranging the letters in something, right? Like ABC is different than BAC, right? In a permutation, these would be different. In a combination, order doesn't matter, right? Like a pepperoni and olive pizza is the same as an olive and pepperoni pizza, right? So we don't want to count that twice as 2 different pizzas. We only count it once because the order of what is happening doesn't matter. So permutations, it would get counted twice. Combinations only gets counted once. All right, so let's practice a few of these and decide if we have a permutation or a combination. Okay, so arrangement of 10 books on a shelf. So imagine the arrangement is different if they're in a different order, right? So in this one, order matters. It's a permutation. Okay, a committee of 3 people out of a group of 10. So this one, if you have Bob, Jill, and Dan, it's the same group of 3 people. If you had Dan, Jill, and Bob, that's the same people. So this one, the order doesn't matter. It's a combination. Okay, class presidency, where the first person is president and the second person is vice president. In this one, the order does matter because you have president and you have vice president. So if you have Joe as president and Bill as vice president, it's not the same thing as Bill for president and Joe for vice president. See how the order matters? It's different if you change the order. So this one is a permutation. Next one, draw a hand of 6 cards from a deck of cards. So if you have 6 cards in your hand, does the order that you're holding them make it a different hand of cards? No, it doesn't. So the order doesn't matter. This is a combination. Next one, number of ways to make a license plate. That was just like our warm-up one. So in a license plate, the order does matter. If you put the letters and numbers in a different order on a license plate, it's a new license plate. So the order does matter, permutation. Okay, so basically what you ask yourself is, if I rearrange the order of things, would it be something new or would it be something the same? So if you rearrange, it's something new, that's a permutation. If it's the same, it's a combination. Okay, reaching your hand in a bag to pick 3 marbles. So this one, the order doesn't matter, right? if you get a red marble, a green marble, a blue marble, it's the same draw as blue, green, red, right? So if you rearrange the order, it's the same thing. So this is combination. A coach picking 5 players to start a basketball game. Again, it's a combination, right? You have 5 people. If you rearrange their order, they're still the same team, right? Choosing 2 toppings out of 10 options for an ice cream sundae. And again, this one, the order doesn't matter, right? Fudge and peanuts is the same as peanuts and fudge, right? The order that you put them on top doesn't matter. Okay, so let's try some now where we actually have to calculate. So a college basketball team has 13 players. In how many different ways can the coach choose the 5 starting players, assuming that each player can play any position? So 5 players, and in this one, that means the order doesn't matter. You have the same 5 players are the same team, right? If you switch their order, it doesn't matter because it says each player can play any position. So order doesn't matter. That means this one is a combination. And we have 13 players and we're going to choose 5. Okay, so you can use your calculator here and do NCR 13, 5. Okay, and that is 1287. So another way that you might see this written is you might see it written like this, C13.5. It means the same thing, okay? All right. A pizza shop offers 9 different toppings. How many 2-topping pizzas can be made? So again, this one is a combination again, because remember, if you have olive and pepperoni, it's the same pizza as pepperoni and olive. If you switch the order of the toppings, it's still the same pizza, right? So in this one, we're going to do 9 toppings, choose 2, right? Or you might see it like this, right? There's 2 different ways that that's commonly written. So I'm going to type in the NCR 9, 2, and we get 36. All right, example 4, 8 people are running a race. How many different ways can they win the gold, silver, and bronze medals? So this one is a permutation because you have the 3 different positions are actually different from each other, right? So if person number 1 wins gold, person 2 wins silver, person 3 wins bronze, that's not the same as if you switched the order, right? If person 1 and person 2 and person 3, right? They get a different medal. Switching it changes things. Order matters. So this one is permutation. And so we're going to use the counting principle on this one. So again, we have gold, silver, bronze. And you have 8 people possible to start with, and then 7 people possible, and then 6 people possible. So it's 8 times 7 times 6. And that's 336 different ways. All right, how many ways could you list your favorite 3 desserts in order from a menu of 10? All right, so this one, does order matter? So this time you're listing your favorite 3 desserts, so like first favorite, second favorite, third favorite, right? So this one, if you switch the order, it would be different, right? So if you have like cake, pie, ice cream, and you like cake the best, you know, if you switch it and put ice cream first, that's a different order, right? That's different than liking cake the most. That would mean liking ice cream the most. So then it's different. So in this one, the order does matter. So this one is a permutation. So we're picking 3 desserts. We use the counting principle. We have a menu of 10. So you have all 10 to choose from for your first favorite. After you choose that, you've got 9 left and then 8 left. So it's 10 times 9 times 8. And that is 720. Next one, after the game, 24 players all shake hands with every other player. How many handshakes occurred? So this one is a permutation too. So you imagine, right? What happens is you have, this one's kind of complicated. So if you imagine you shake hands, so you have 2 people shake hands at a time, right? So 2 people at a time. So here's person 1 and person 2. You have 24, all 24 people, and then you have 23 left. So it's 24 times 23. And that is 552 different handshakes.